Okay, so let's do a very quick unboxing of the accessories you'll receive when you get your HAL product. As we move through the unboxing, I'll explain exactly which products you'll get in which model you order. So let's start. Firstly, you'll have your user manual. All products will receive a power cord, a Hipot return probe, a Hipot output clip, a download cable for data transmission, and a set of connectors. Now these connectors will have various functions such as pass or fail or a remote start-stop connection. You'll also receive, if you have a 103 or a 104, a green cabled earth probe, and finally again a 104 LED or 103. You'll also receive an output box for making connections. So those will be all the accessories that you'll receive within your HAL. So in this section, let's have a look at the features on the front of the HAL. Now all HAL models will look identical from the front, the only difference being the identifier on the label, but all of the features that you see on the front will be the same across all models. So firstly, we have our LCD display. That's where all the majority of the information to the operator will be displayed. Beneath that we have 4 function keys. Now those function keys will have various features dependent upon the screen you're in at the time. We have our power button, a simple on-off switch for the HAL, and above that we have our pass and fail lamps. So during the test, if everything is good, the pass fail will be illuminated. If for any reason the test was to fail, the pass light is turned off and instantly the fail lamp will come on and will be displayed bright red, giving a good indication to the operator that something has failed. Along with that, there will be an audible tone to alert the user to the fact that the unit's failed. Beneath the screen we have our start and stop buttons. So those act in a number of ways. They allow you to enter and come out from menu screens. They also start and stop tests accordingly. We have our rotary encoder to allow us to navigate around the user interface. And then beneath that we have some test outputs. So you'll see the 2 white ports, 1 negative, 1 positive. That's where we can make our test connections for tests such as the Hipot test or the insulation resistance test. In the middle we also have our high voltage illuminator. So at any point where the voltage is deemed hazardous, the LED will glow bright red, alerting the operators that there's potential hazards on the output test leads. Okay, so let's have a look now to the rear of the HAL unit. This is where things start to get slightly different. Different models will have different features on the rear. Hopefully we'll give you a good indication of what's what through each model. Firstly, I'll point out all of the items that are common across all models. So firstly, on every HAL model we have a beacon port. So this allows us to connect to an external beacon, and that beacon essentially goes from green to red whenever the area is potentially unsafe. So whenever the HAL is performing a test, the beacon will be switched from green to red to alert those around the area in accordance with 50191 that the area is potentially unsafe. Beneath that we have some connection points. So we have our connection for data transfer. We have a connection to a barcode scanner so the operators can scan barcodes. We have a connection to a printer. At the end of the test, the HAL can be programmed to print out pass or fail labels accordingly. We also have on all models a voltage selector switch. So this allows you to turn the mains incoming voltage, whether or not you're running from a 230 or a 110 volt supply. We also have our guard plug. So our guard plug is a safety connection switch that allows us to stop the test if for any reason the safety switch is broken. So this is commonly used in things like enclosures. When someone opens the lid of the enclosure, the HAL can be programmed to instantly stop the test, providing the enclosure switch is connected to our guard switch feature. Again, across all models we have some level of input and output connections. Commonly across all models, we have pass or fail connections. We also have remote start and stop connections. So if you didn't want to use the green and red buttons on the front of the unit, we can start and stop the test remotely. We will always have a power supply input, and all units have a fan for assisted cooling to keep the HAL cool whilst running. Once we reach the HAL 103 model, and then onto the 104 and the LED models, they will all have a rear connector for test output. In the unboxing video, I showed you the output box. The output box simply connects into this slot here. So if you have a 103 or 104 and you want to use the output box, this is the connection. When we move to the 104 and the LED, we also then have this section, which is our auxiliary input. So one of the features of the 104 or the LED is that we can do powered live testing on products. So we can power the products up, measure the power that they pull, and also measure any earth leakage or touch leakage under mains conditions. Now we have a selector switch here, which is normal or auxiliary. Now what that allows us to do is either to use the mains coming into the HAL to power the appliance that we're running, or we can use the auxiliary switch, in which case we can put a power into the unit or a voltage into the unit that isn't the native power supply. So for example, we may be running in the UK, we're powering the HAL from a 240 volt supply, but we're manufacturing equipment for the US market, and therefore we need to do the power test at 110 volts. At that point, we can simply feed 110 volts into the two ports here, the red and blue port, flick the switch to the auxiliary, and when the time comes to power the equipment up, it will actually feed through the 110 volt from the auxiliary ports. So that's the rear of the HAL. We'll move on to start to show you some of the features on the user interface. In this section, we're going to talk about creating test connections when using the HAL tester. Now firstly, we'll start with the HAL 101 test connections. We spoke about this earlier on in the video. We have our positive and negative outputs. So in order to make tests for HAL 101, we would simply use our Hipot return probe and our Hipot clip. Now typically the best way to make the connections here would be to use your clip for the positive connection and your Hipot probe as the return. Now when performing tests, we have the Hipot voltage coming and being applied via the clip, and then we simply use the probe to make the test point for the return. So the probe itself is sprung loaded, so the tip is only displayed when the button is pressed at the top of the probe. Now again, this is for safety, so we have hand guards to stop us coming into contact with the high voltage, and similarly on the clip we have a rubberized finger protector to stop us getting too close to any output voltage. If you have a 103 or 104 or an LED model of the unit, tests can be made via a rear connection connected to our output box. Now on our output box there are three main connections. You'll see there is a output plug socket. This can be regional, so we do have variants for Europe, Australia, America. We have a port for our Earthbound probe, and we also have a Hipot return for anyone manufacturing class 2 products. So for an Earthborn test, let's start there. We have our green cabled Earthborn probe. This is made by placing that into the connection and just twisting to lock in place. Now test connections are made between the tip of the probe and the earthing point on the socket. So we would typically plug our product in, we would take our clip, we would place that, or our probe, sorry, we would place that onto the exposed metal surface of the product and use that to test for our earth continuity or Earthbound test. Hipot testing can be performed in one of two ways. If we have a class 1 appliance, then Hipot testing can simply be performed between the live and neutral conductors strapped together. The HAL will strap these two together. There's no requirement for the operator to make any kind of connections. This is done automatically within the tester. and the earth socket. So we would send our high voltage out through the live and neutral and measure any return into the instrument via the earth socket. If your product is a class 2 that you'll be testing, we would still use our live and neutral strapped together as the output, but in this case we would use our return for measuring any stray current. So in that case we could use either our Hipot clip or the Hipot probe we spoke about before, place those into this connector, and then use your probe or your clip, connect it to any exposed conductive parts on your double insulated product, and we'll measure for any current flow returning back into the instrument. We're now going to take a look at the HAL user interface. As such, we're going to be programming in a test sequence, and we'll also show you the performance of a test a little bit later. So at the moment the HAL is in its main menu pose. When first loaded, this is the screen that you'll be presented with. You can configure the screen to load into various different modes. So for example, should I want to, rather than showing any kind of menu system, I can load the HAL directly into test mode, so that as soon as it's switched on, it's ready to test. But we're going to start from the main screen that you would all see as you first load your HAL on first run. So in order to navigate through the menu screens, I'll typically be using the rotary encoder to move us around. As you'll see, the cursor is scrolling as I move the wheel. I'll also be using one of the soft keys dependent upon the menu screen I'm in and as to what function that will perform. So very briefly, before we show you some of the screens, we'll just talk about the different ways the HAL can be controlled. There are a number of ways you can perform tests when using the HAL. It can be used in a manual mode, so if you wanted to completely manually perform your tests, for example in a conformance laboratory, then you can do single stage manual tests as often as you need. We can also remote control the unit, so if you did want to set up a piece of software of your own or control the HAL using an external software, you can send commands to the HAL, engage it to perform tests and receive responses back regarding kind of test results, etc. But the more common way that this is generally used will be in its own test sequence mode. So that's what we're going to demonstrate and set up for you today. So from my main menu, the first thing I'm going to do is go into my setup. And what we're going to do in this stage is show you a configuration of a test sequence. So you'll see our first menu option is edit test settings. So we're going to go into edit test settings. Now by default we put 3 dummy test sequences in there just to show you and get you used to the kind of user interface. In total we can store up to 50 different test sequences within the HAL. So let's pick a blank test and let's go in and have a look at the test sequence. So as it currently stands, everything is skipped. So we have a completely blank test sequence, and what we're going to do now is program in some tests. So you'll notice we have 1, 2, 3, 4, 5 different tests that we can perform within a sequence. So we can program 5 individual tests for any test sequence we want to perform within the HAL. Now within each of those tests, as we'll show you a little bit later, we can do repeats. So if we had more than one Earthborn test, we don't need to use 2 slots up here to perform the Earthborn test. We can simply repeat the single test that we've created a number of times. So what I'm going to show you today is a typical test for something household. So we're going to create a Earthborn test and a Hipot test needed for the routine production line test requirements, but we're also going to add in a functional test, in which case we'll power the equipment up and get it to run as expected. So in order to create a new test, we can use the wheel to skip around fields, or we can alternatively use the wheel to change the field. So that's what I'm going to do in this stage. I'm going to highlight the rotate field option. Now what that means is anytime I turn the wheel, that will alter the field for which I'm trying to edit. And to move the cursor around, I simply use the previous and next field options. So let's move to our first test, At the moment it's skipped because there's no test programmed, and we simply use the wheel to define the test that we want to perform. So we're going to perform an Earthbound test. We can now set the parameters for the test up. So things such as ramp times, hold times, outputs, whether that's current or voltage, depending on the test you're going to perform, limits, if you have any limits you want to set, the number of times you want to perform the test, and also how you want to start the test. So there are a number of different ways we can start any single test within a test sequence. So let's skip. So here we have our ramp time, we have a hold time, and we have a ramp down time. Now for this test, I'm just going to perform a very quick 2-second test. So I'm going to leave that as is. I would perform the Earthborn test at a minimum of 10 amps. So we will set the current to 10 amps. And according to the household standard, we'd be looking for a minimum or a maximum of 200 milliohms or 0.2 ohms. So again, I can just use the wheel to dial in the correct amount. There we go. We can put a lower limit in. As for all tests, we can set both upper and lower limits. So if you do have any kind of quality measurement and you want to be absolutely sure you're getting the correct amount of cable, we could set a lower limit. We can also use upper and lower limits to confirm correct test procedures. Now the next step would be to assign the number of times I want to perform the test. So should I choose, I can use the wheel and simply select the number of tests that I want to perform. In this case, for demonstration purposes, we're just going to do the one test. And finally, for this test, we just want to define how we want to start the test. Now, there are a number of methods we can use to start the test. We have the green button, we have the guard switch, or we have a combination of both. Alternatively, you can set the test to none. So in essence, the test would perform the test automatically without any interaction from any person. Now this can be particularly useful when you're sequencing tests that are within a test enclosure. So we may want to press the green button for the very first test and then allow the test to automatically continue, providing all of the tests are passing. So what we're going to do is exactly that kind of scenario. I'm very quickly just going to change the icon to our start condition. So you'll notice the small little button icon. That indicates that the test will start on press of the green button. Okay, so let's move on. We've now created our Earthbound test. The next test we want to perform in the list is our Hipot test. So again, we'll come down to our skip and we'll use the wheel to change the value. In this case, we're going to do an AC Hipot. In terms of all of the HAL units, we can either do a 50 Hz, a 60 Hz, or a DC Hipot test. So for us, we're going to do a 50 Hz Hipot test. Again, you can see we have times, we have output voltage this time because it is a voltage test. We have limits, we have our front and rear connections. We'll talk about those quickly in a second. Again, the number of times we want to perform the test and any start conditions that we want to set. So very quickly, we'll typically set this up for a normal routine test for household equipment. So we're just going to set the test to 1 second. We're going to set the output voltage to 1000 volts. Well, in our case, this is in kV, so 1.0 kV. We need to set an upper limit, so this is the maximum amount of current that can flow before the product is deemed to be a failure. Now, alongside recommendations in EN 60335, which is the example we're doing, the recommendation is somewhere above 5 milliamps should be deemed as excessive current. So we're going to set the limit to 5 milliamps. Again, as you can see, we could set a lower limit should we choose. And And the next thing, for those of you that have a 103 or a 104 or are considering a 103 or 104, we can choose where to send the test voltage. So we can send it via the front ports, which we saw earlier with the 2 white ports at the front of the unit, or to the rear port, which is the output box that we showed you as part of the unboxing. Now, for this particular test, we're going to be testing a product that has a plug, so it's convenient for us to use the socket on the output box. So we're simply going to turn off the front port, meaning we're now only testing to the rear port. Again, we can choose the number of times we want to repeat the test. In this case, because we're testing an Earth product, we're going to be testing the Hipot test via the live and neutral conductors strapped together versus the Earth return cable. So because we've already tested that the Earth path is in existence, it's feasible that any current flow that strays away from the live and neutral conductors should in theory hit any of the external metalwork and therefore would flow back down through the product via the Earth cable of the device under test. So therefore we're only going to need to perform the test once, and we're going to start the test again in this instance just by pressing the green button. So once we've completed that really now gives us the full safety requirements as kind of prescribed by the standard. But as an additional test and as an additional quality measure, we may want to perform a functional test. Now that functional test allows us to be sure that the product under test not only is electrically safe, but also functioning as we would expect. So we're going to select the test. In this case, we're going to do what's called a power and leakage test. Now this does 2 tests in one hit. So not only can we perform a power test and make sure that the power is where we would expect it to be, but also we can perform what's known as an earth leakage test. And that earth leakage test defines any current flow, any stray current flow in the earth cable whilst the unit's in operation. Effectively, this is a kind of supplementary test to the Hipot test. In theory, if we have Hipot leakage, we would have earth leakage and vice versa. So there are a few parameters we need to set for this. The first thing we need to set is our power. So ideally we would know what the nominal power for the unit is at a set voltage, and therefore we could set an upper and lower limit accordingly. At this stage I'm just going to leave these blank. We can define how long we want the product to run for. So if we know there's a longer time for it to build up to its maximum power, we can run that for a longer period of time. Something like a light, for example, pretty much reaches full brightness within a second or two. So these tests can be very quick. We can also set our leakage value. So again, dependent on the test you want to perform, you can set a lower leakage in accordance with the standard and an upper leakage if prescribed. These aren't always necessarily set for routine tests, but there are some values for 60335 we could set in accordance with the standard. In this case, we'll assume we're testing something that is portable. So we'll set the limit to 3.5 milliamps. Finally, again, we can set whether we want the polarity to be standard, as in mains in and out. We can also reverse the polarity if your standard calls for reverse polarity tests. But for today, we're just going to perform it at standard polarity. We know the incoming mains on our circuit here for today is correct. The live and neutral are in the correct orientation. So we'll perform the test in a standard polarity. In some routine tests and some conformance tests, it is a requirement that you switch between standard and reverse polarity. So if you do have to do that, the HAL can sort that for you. Finally, again, we can set how many tests we want to perform, and again we can set a start condition. For all of our tests for today's example, we're going to set to start when I press the green button. So this is essentially now the test sequence created. The final step is to give the test a name. So we can scroll down to the name, press the green button, and this then allows us to edit a test name. And for today, we'll just call it demo. Press the green button, press the OK key to confirm, and that test you can see now is in our test sequence list. Simply press the red button to come out. That test is now stored and it's ready for use. Okay, so we've created our test sequence. We can now go ahead and perform that test sequence. So in order to show you and demonstrate the test procedure, for this particular demonstration we're going to need our earth probe and we need something to test. So for today's demonstration we're going to use a small travel iron to demonstrate. So the unit is a class 1, meaning it has an earth. So we're going to run through the test sequence we previously created. So at the moment you'll see the HAL is ready to accept some data in order to create the test record for this particular product. So at this stage it's prompting us to put in a unique reference number that relates to the item under test. Now typically this would be a serial number. If your serial number is a barcode, the HAL can accept the barcode scanner, so we could simply scan the serial number. But just for demonstration purposes, let's put a number in. So next step is we need to pick the correct test sequence for the item we wish to test. You'll see on screen we're now being presented with our list of test sequences, and if you can make it out, we're going to be performing the test demo that we previously created. So let's go ahead and pick that test. Okay, so we're now instantly into the test sequence performance screens. You'll notice on screen we have some information regarding the test. The right hand side gives us our pass-fail graphs and our output current in this case because it's an Earthbound test. The other thing you may have noticed is the probe is flashing. So the probe is used to give feedback to the operators when it's needed for the test. So you'll notice right now it's flashing very rapidly. So that's the indication to the user that this probe is required for the test. Now during the test the probe will continue to flash, but it will slow down to show that the test is in progress. Once complete, the probe will also then give indication to the operator as to whether the test passed or failed. It does this by, if the test has passed, the light on the probe will stay green. If it fails, the light will go out, and we'll also get visual indications on screen. So let's start the test away and see if it passes. Firstly, I need to go onto the metallic surface of the product. The probe also acts as the start button, so I don't necessarily need to press the green start button in order to test the product. Simply take the probe, make contact with the metallic surface, depress the probe, the test will begin. Providing everything is good, the test will pass. You can see the pass indication. We can then remove the probe and the HAL will move on to the next test. Now it's ready to perform the Hipot test. Again, because this is a class 1 product, all the test is performed between the live neutral and the earth cable. So we don't need any probes in this particular instance. We can simply start the test away when we're ready. If your product does have an on-off switch, always ensure it's in the on position. If it has any speed settings, heat settings, it's good practice to make sure they're always generally set to max, and any switches that are on are in the on position. So we're good to go. We'll start the test away. The unit will output 1000 volts for a second. Providing the leakage again is less than the limit, the test will pass and move on to the next test. And the final test here now is a run test. So we're going to power the iron up. We will get an indication of the amount of power the thing pulls, in this case via a VA reading, and it will also give us any earth leakage flowing back into the device under normal operating conditions. So again, we'll just press the green button. The test is started. We can see it's pulling around 730 VA. Test is complete. The sequence is over. The unit has passed, And in this case, we're set up to view a menu screen once the test is finished. So this menu screen allows me to demonstrate to you the kind of record that the HAL is actually storing. So we'll pick review test results, and you can see on screen now this is all the information that's stored within the HAL's memory regarding the test itself. So we can see the product, i.e. the serial number. If you do put things like sites, locations, or even users in, it will log all of that information. Date and time that the test took place, the overall result, pass or fail, and then we come into the actual measured values for each individual test. So you'll see on the left hand side, these are the tests that were performed. So we have our Earthbound, our Hipot, and then 3 measurements for the leakage and power. So we can see we outputted a 10 amp test. The limit was between 0 and 200 milliohms. Our measured value was 111 milliohms, therefore the unit passed. Similarly for the Hipot, our output was 1 kV. Our limit was 5 milliamps. The unit measured 0.17 milliamps, and therefore it passed. So all of this is now stored within the memory of the HAL, and it can be freely downloaded, transported to a PC for digital record keeping. Okay, so we're going to demonstrate that test sequence again. However, this time I've made some slight tweaks to the test procedure. I've removed any start conditions on the following tests after the first one. So we're going to use our probe to start the first test, and after that all subsequent tests will start automatically without any human interaction. This just shows how quick the HAL can be set up within a production environment, and how quick it can perform the tests. So as before, we would need to put a reference number in. Again, for speed, barcoding is great. We can select the test sequence. Again, if we have a barcode, we could scan a barcode, but now we're ready to do the test. So in this instance, I simply start the test off with my probe. Once that's finished, the probe can come away. The test is then performed automatically without any human interaction. And providing it's good, the test is passed, we can go on and be ready for the next test.